Hi lads, in this video I'm going to go through how to 2015 section C2 question in higher level. It tells the graphic on the right shows a pack of potato crisps. These potato crisps have a distinctive surface shape, which is based on hyperbolic paraboloid. The projections of one of the crisps are shown in figure C2 below. The perimeter is an ellipse in plan. The surface of the crisp is formed by extending the hyperbolic paraboloid surface ABCD. Part A is to draw the given plan using the same number of elements in each direction on the surface of the crisp as shown. Part B, project the given elevation from the plan. Part C, show the curvature of the surface when intersected by a vertical cutting plane passing through points B and D. And then Part D, draw the plan and elevation of the shortest distance between the two skew lines AB and CD. So to start off this question, I'm going to draw the ellipse in plan. So I'm going to take my horizontal line across the page, and I'm going to start off here and label that as A, and it's at a scale of 2s to 1, so I need to double up my 75mm, so 75 is only going to be halfway across, and 150 is going to give me corner C, and then I'm going to take my vertical line going through my axis there, and I'm told that it's at 35 degrees from A. So I can take my 35-degree line and out here, and that'll give me corner B there. And if I just get my compass, I'll be able to take that distance there, swing it around there, and that'll give me corner D. And I'll just connect those together. So A connects to B, B connects to C, C connects to D, and then D connects finally back to A. Now for this question, you can see if I just get it back up there for you, and just zoom right in on the actual plan, you can see that there's actually going to be a lot of lines in the question. So instead of doing the concentric circles method, where you get your major circle and your minor circle, I'm going to actually use the trammel method instead to reduce the number of lines on the actual question. So to do that, you get your trammel, so you just get a length of paper like this here. And what you do is you mark out a point here at the end, and you take half your major axis, which I've labelled as B there, and then you turn it around and you take half of your minor, so the distance from P to A, and that's what you're going to use for your trammel. Just have to fix the light there as it was creating a shadow on the page. So as I was saying there to you, you get point P is going to be the outside length there, all the way around, and you take half the major, which is from P to B. You then turn around this way and take half your minor, the distance from P to A. What you're going to do is you're going to use them 2 points to mark all the way around your points on the actual curve then. So for example, if I line it up like this here, and I tilt it ever so slightly, make sure they're touching off your horizontal and vertical lines, and you can put a dot there, move it a bit more around. So you remember this from when you were doing your junior cert, would have been a method you would have been taught. There's another point there, and we just keep moving around. We can take as many points as we like, just making sure that A and B are always touching off our horizontal and vertical lines. And that will give me one corner there, for example. What I can do then is move it around for the bottom half, right to the top half here first. Just a bit of mucking around when you're actually trying to get it. So I start here and I'm tilting around this way. You just keep plotting your points around and making sure that you actually keep these 2 points A and B always on your line. otherwise your curve will go slightly off. Just move another one around here. You'll see I could do one more just here. Then repeat the process for the bottom half. So line it up again, tilt it around, hit a point here, tilt it around a bit more. And I'll just take one more here. So you can see there I have a set of points going all the way around now. And finally the last corner here. So using this side here then as a result, you get the last section. Making sure they're on the line. Point there. Point there. You can kind of see what I'm doing. It's kind of a bit tricky sometimes trying to figure out exactly which corner you're actually trying to join up. Just always make sure the point P is always touching the outside when you're moving around. Take another point here, another point here, I'll take one more here, and just the last one just to close it off there. And that'll give me enough points to actually draw a nice neat freehand curve. So remember to keep your curve nice, neat and free flowing. And the only reason I'm actually using the trammel method here is just for the sake of having the least number of points possible and lines taken around, as there will be a lot of elements and it's very easy to mix up the question. The solution actually given online shows the auxiliary circles method, and if you actually look at it you'll find it's very, very hard to follow. As the circles have been divided up, you have 30, 60 lines, you have points up and points coming across, and it can just look a bit of a mess to actually try and figure out what's actually happening. So what I'll do now is just go over heavy what I've actually drawn. And remember to get up and actually move around while you're trying to draw your curve. So just keep your wrist in the one place at all times. Allow it to actually be able to move around while drawing the curve. So you can see the way I'm always moving my hand so I can have my wrist to actually move around when drawing the curve. And there's my curve now drawn in plan. As you can see, very minimal with the amount of lines I actually have drawn. I still only have my A, B, C and D drawn now, and then my actual axis connecting the two. After I want to now draw in my actual elements. So I need to divide up it into a total of 1, 2, 3, 4, 5. So I need to divide up my line, for example, AD into 5 equal parts. And we'll have 4 elements running along those. So what you do is just take a line out, I'll take it outside of it, so it doesn't interfere in the inside of the question. And I'll step out 5 equal distances from there. And then connect those back to D. And then just using slide and set squares, I can take them in to see where they hit line AD. And then finally the last one there. And because this shape here is symmetrical over this side and then symmetrical over that side there, I can just take those points up and across, save me dividing up the other sides as well. So I have a point here, 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 and finally here, and then just take these up as well to give me the top. You can see once again I'm actually drawing A lines, I'm just dotting where they're going to go. Just reduces the number of lines that are actually going to be drawn on this page. and it'll make everything so much easier to follow when doing the question out. And then finally the last one. So this question is very similar to the previous one we've looked at. I think it was 2018 paper where we had the bridge and the roadway. What we're doing is we're drawing our elements and we're going to extend them out to actually hit our ellipse so we can actually plot out that curve in elevation. And then take our points going this way as well. So you can see the amount of lines now I actually have on my page, and if you can imagine what it would have been like if I had divided up my 30/60s and everything to actually draw out the auxiliary circles method, it would have created a lot of trouble for the actual question. It would be very hard to follow. So for now I'm going to finish off my plan there, and I'm going to take up my points A, B, C and D to actually draw out my curve in elevation. So from the question I can see that the height is 25, and when I change the scales it will give me a total of 50 up. So that 50 up there is for the points B and D. C is on the ground here and A is on the ground there, and we connect them together. A is going to connect to B, B connects to C, and then C connects back to D. So you can see C and D are already connecting there. And I just draw lightly in between them so where my elements hit them. And I can draw the same in my plan as well. Now we do the exact same process as before. What I'll do is I'll label my sides here, all my elements. 1, 2, 3, 4 there. There's 4, 3, 2, 1. I'll label these 5, 6, 7, 8, and 8, 7, 6, and 5. So the idea is first to take up the actual elements where they hit the lines A, B, C, D. I can't take up these points yet because I need to actually plot out where the elements are going to hit off these surfaces here. So the first thing I want to work on is between A, B and C, D. So I'll take up 1, 2, 3 and 4, and you'll find that 5, 6, 7, 8 are actually going to hit off them anyway because them points are the same above and below. For example, 3 and 7 are going to be on the same line. So I'll just take up the points from the top section, 1, 2, 3 and 4 there. And I just label them 1, 2, 3, 4, and take them up this side. I have 4, 3, 2, and 1 there. So connect them together first. 4 connects to 4 there. 3 connects to 3 there. 2 connects to 2. And finally 1 connects to 1. So you can start to see when that just focuses, you have a natural curve starting to form below that you can draw on heavy. But for now I'm just going to get the top half of the curve done and then focus on drawing the bottom half after. So all these elements are going to extend out to where they actually hit the ellipse. So for example 4 here on this side, and it's also shared with 8, but just for the sake I'll just take up 4, that will extend out to here. I'll extend 4 out here as well, and when it extends out it touches that point there, and that's 1 point on the outside of the curve. I'll do the exact same with 3. 3 extends out to the ellipse here. I take that up, I extend 3 out. That gives me that point there. Repeat the process with 2. 2 extends up to there, and when 2 is extended out this side, I get that point there. And then finally with 1, 1 extends out to hit here. I take that up, and 1 will extend out to there. And now I have points going all the way along that I can draw my curve on this side. All it's a matter of doing is extending them out on the opposite side as well. So for example 4 here, 4 extends out to here. Get 4 and 4 there, extend it out, I have a point here. Take where 3 extends out, extend 3 out as well. And the exact same with 2 and 1. So 2 will go out there, 2 connects to 2, that's another point, and the final one then, where 1 extends out, I can extend 1 and 1 out to there. And what I can do then is I can just label my 5, 6, 7, 8 as well. So I have 1, 4 here, 2, and 2 is on the same line as 6, 3 is on the same line as 7, and 4 is on the same line as 8. And that allows me now to draw in my curve in elevation. So what the crisp actually looks like now, just by extending the elements. And what I'll do after this is I'll just put in colour just to show maybe one of the elements, just to make it quite clear what's actually happening. So there's my curve now drawn in. I just draw an element in and then draw it in heavy after. Just using this orange for example here. Just showing elements 3 and 3 there. So with that element 3 and 3 there, I would have taken them up, and 3 and 3 would have hit off each other there and there, and then when I extended them then in plan, they would have extended out to there and there. So showing 3 as this one here, and showing how they extend out to me these points here and here. So I'll just draw it in heavy. And remember to keep it as a continuous line, not anything jumping out along the way. That gives you that line there. And as I said to you, just basically just kind of draw a freehand curve where it touches off the elements basically, like tangent edges all the way along. And then just go over that heavy then as well. That then completes our elevation, showing all of our elements, extending out and drawing both of our curves. For the next part of the question, they want you to draw show the curvature of the surface when intersected by a vertical cutting plane. So basically, what does that surface look like when we cut through this area here? So basically what you're going to do is, you're going to draw an end view, looking in this way here. You can look in this way as well, but just for I set up the question, I'm going to have the end view looking in from this side. So it's basically what we see where we cut along that surface BD. So that's basically the same as drawing an end view, because our auxiliary view is going to be coming out this way anyway, so it's the same thing as drawing an end view. So what I'll do is I'll take across my heights there, and take across A, B, C, D in my plan. So already I get 1 point in my curve there for B. C and A are on the ground, but for the purpose of this part, it's only that cut surface here. It won't be drawn the full view. It's only drawn that section there. So still the center point will be that very bottom point there where the curve goes round. And then finally D is going to come up here. And we'll label that as D as well. So what I need to do is find points along that actual surface there. So what I can do is I can use my actual elements here and where they cross over the line BD. For example, I have a point here that crosses a point here. I already have my center point, and then I have this point here and this point here. What I'll do is I'll label them as A, B, C and D. And what I'm going to do is I'm going to take A across first, for example. So A comes across there, over and up, and somewhere along that line there it's going to be the height of A. So when I look at A, it actually lies along the element 4 and 4. So what I do is I follow 4 and 4 until I find where it crosses that central axis of A, and it crosses just there at that point. So you can see the element 4, 4, it crosses the axis BD there. And I can take that across. It gives me that point there. I repeat the same with B. B comes across up at 45. It's going to be somewhere up there. I can see that that's on the element 3, 3, the one I drew in orange. So I follow element 3, 3 across. Gives me that point there. So the orange line in elevation. And I now have that point. I'll just let it focus there for a sec so you can see it. So I have them points there now. 1, 2, 3 and 4. And I'll just label them as well. So that's going to be point A, B, and then C and D. Because it's equal on both sides, they're symmetrical. What you can do is you can take the height here over and the height here over, and just to save my lines are drawn, you can step them out each side. So you're going to get D there, and you're going to get C there. All it's a matter of doing is basically drawing out a nice neat freehand curve again, and that's just showing that cut surface there. And then just go over in heavy then as well. And that's the true shape then of what that surface looks like when you actually slice it along that beady surface there. So it's not just drawn a full end view, it's drawn